Hello friends, welcome to Input Output Campus. So today we'll discuss about the binomial coefficient. So first we'll see what is binomial coefficient, and next we'll see the expansion of binomial coefficient, and next we'll see how to solve the coding questions of binomial coefficient, and finally we'll see the dry run of the binomial coefficient code. Okay, so this is the most interesting part because here we'll learn how the binomial coefficient internally works and how the recursive function is called internally. And if you have any fear or doubt about the recursive functions, then after this dry run you will feel more comfortable and more confident about the recursive function, because in this dry run I will show you in an easy way how the recursive functions are called and how to calculate the values step by step. Okay, so be patient and watch the whole video from the beginning to the end, because here we'll learn many things. Okay, so what is binomial coefficient? So binomial coefficients are the number of ways to select a set of k elements from n different elements. Suppose there are 20 students in your class and there are 2 books. So how many ways these 2 books can be given to these 20 students? So if these types of problem arises in anywhere, then you can use the binomial coefficient. So binomial coefficient is denoted as CNK or NCR. So you all know the formula of the combination NCR, but here is the problem. So when you write the code, the compiler does not know what is NCR. So for that you have to write a function. So suppose C is a function and here n is this n. So this n will be written here and k is actually the r value. So you have to write a function for that. So what is NCR? NCR is defined as coefficient of x to the power k in the binomial expansion of 1 plus x whole to the power n. So here k and r is the same. So if we write the binomial expansion of 1 plus x whole to the power n, then the coefficient of x to the power k will be the NCR. So here you can see we can write down the binomial expansion of 1 plus x whole to the power n as like this. So suppose here our k value or r value, these both are same. We have to write it differently. So these both are same. So suppose k equals to 3. So x to the power 3, the coefficient of x to the power 3 is what? So you can see here the coefficient of x to the power 3 is n into n minus 1 into n minus 2 by factorial 3. So which is the coefficient of 3? So which is nothing but the NCR. So NC3. These two are same. So suppose our n value is 8 and k value is 3. You can calculate the coefficient of x to the power k, that is x to the power 3, is 8c3. So in the binomial expansion, if you write the value of n, that is 8 here, 8 into 8 minus 1 into 8 minus 2 by factorial 3, then this value will be same as this 8c3, because 8c3 and the coefficient of x to the power 3, that is n into n minus 1 into n minus 2 by factorial 3, these both are same, and these both will give the same output as 56. Okay, for calculate this value in the coding, what we'll do, we'll write a function here. We have to write a function here because we can't write this NCR or NCK in our code. So for that we have to write a function. Suppose C is a function and we'll pass this 8 and 3. So n and k will be first here, and this is a recursive function. So we'll call it recursively. So first we'll call the same function, but we'll decrease the n value by 1 and k value by 1. Next we'll add this value and call the same function again, and next the n value but k value will be same. So know to make a recursive function there is 2 conditions. So first is you have to write the base conditions. So what is the base conditions? Base condition is when the recursive call will end. So from the end it will be go back to the recursive function again and calculate the value. So we will see all this into a dry run program. So to make a problem recursive, the first process is you have to write the base condition where the recursive call will end, and second one is you have to write a recursive function wisely so that the recursive condition is satisfied and our value is calculated. So this is our recursive function and this is our base conditions. So first we'll see the code how this recursive function works, then we'll dry run it. Okay, so you can see here we have to write a code in the C++ language. So first the code will run from the main function. So we come to the main function and here our n value is 8 and k value is 3. So next we call a function binomial coefficients and pass this n and k. So n will be come to here and k will come to here. So in n 8 will be stored and in k 3 will be stored, and it will check if k equals to 0 or k equals to n, then it will return 1. Otherwise it will call the binomial coefficient function again. So it will call this function again, but for every time it calls the function it will decrease the n value by 1 and k value by 1, and it will add this with the another recursive call of this function, but this time it will decrease the n value by 1 but k value will be same. So how you will know that what will be our base conditions for this problem? So you can see here k equals to 0 or k equals to n. So if you remember that n ck, so if we write the k equals to 0 in our n ck formula, so write the n value as anything in the n ck formula and k value as 0. So you will see that for every time you will get the result as 1. So for the another conditions like k equals to n, so if k and n are equal, so in the formula n ck, if n value and k value are same, suppose 125 c 125, and if you calculate this in your calculator 125 c 125 or anything, any value of n and k, then you will see that every time the result is 1. So this is the base conditions. So the problem is here that how you will know how to write these recursive functions. So we'll dry run this and we'll understand how this works. Okay, so first what we have done, we have decreased the n by -1 and k by -1 for the first time, and we'll add it to the next recursive function and decrease n by 1 and k value will be same. So remember these two things. For the first time we'll decrease the each value by 1, but for the second time we decrease the first value and second value will be same. So please remember this, because in the dry run for every steps this formula will be needed. And our initial n value is 8 and k value is 3. Okay, so let's see the dry run. So here is a dry run. So our initial n value was 8 and k value was 3. So in our recursive call, we first decrease the n value and k value by 1 and 1. So our n value was 8 and k value was 3. So it will be decreased to 7 and 2, because 8 will be decreased by 1 and it will be 7, and 3 will be decreased by 1 and it will be 2. And for the second recursive call, n value will be decreased by 1 but k value will be same. So we'll see for the first recursive call, and we'll call the every recursive function till the base case is satisfied, and then we'll call the next function 7.3. So if 7.2 is called, then again the same thing will happen here. So here 7 will be decreased by 1 and 2 will be decreased by 1. So this will be 6.1, but here 7 will be decreased by 1 but 2 will be same because k will be same here, and we'll add these two. And we'll check here if the base condition is satisfied, if k equals to 0 or n equals to k. So no, the base condition is not satisfied. So we'll call this first function again. So 6.1 will be called. So again we'll do the same operations here. 6 will be decreased by 1 and it will be 5, and 1 will be decreased by 1 and it will be 0. And for the next time it will be 5 because n will be decreased by 1 but k will not be decreased, so k will be 1. So here you can see, so here our if condition was if k equals to 0 or k equals to n. So here one condition is satisfied, k equals to 0, so it will return 1. So we'll write here 1 here. So we'll write 1 here, and next we'll call this function again 5 and 1. So you know what will be the next step. So after calling this 5 1, this will be 4 0 because 5 will be decreased by 1 and 1 will be decreased by 1, and we'll add it the another recursive function call where n will be decreased by 1 but k will not be decreased, so k will be 1. So here we'll check the same conditions here, if k equals to 0 or k equals to n. So here you can see k equals to 0, so this condition is satisfied, so it will return 1. So we'll write 1 here. So next we'll call this for 1, and you know how to write the next step. So here will be 3 0 and here will be 3 1. Okay, so here we'll check the same conditions, if k equals to 0 or k equals to n. So you can see here k value is 0 and 1, so one condition is satisfied, k equals to 0, so this will return 1. So we will write 1 here. So next 3 1 will be called, and it will be 2 0 and 2 1. So here we'll check if k equals to 0 or k equals to n. So here k equals to 0, this condition satisfied, and this will return 1, and we will write 1 here. Next 2 1 will be called, and here will be 1 0 and 1 1. So here you can see our n value is 1 and k value is 0, and here n value is 1 and k value is 1. So here are two conditions satisfied. So our first condition was if k equals to 0, yes, k equals to 0, so this will return 1. And if n equals to k, yes, our n value is 1 and k value is 1. So these two are same, and this will also return 1. And all the recursive call reach to is base condition. So we'll return this two value. So here what we'll do here, so here is a plus sign, so we'll add these two value. So 1 plus 1 will be 2, and this will be returned to 2 1 because these two came from these 2 1. Okay, so 1 and 1 will be added, and the value is 2 will be returned here. And here you can see the value of 2 1 is 2 and the value of 2 0 is 1. So these two will be added because there is a addition symbol, so these two will be added. So 2 plus 1 is 3. So these 3 will be returned to here 3 1 because these two came from this 3 1. So here will be 3. So the value of 3 1 is 3 and the value of 3 0 is 1. So 3 plus 1 will be 4, and these 4 will be returned to this 4 1 because these two came from this 4 1. Next 4 and 1 will be added, and 4 and 1 is 5, and 5 will be returned to 5 1. So because the 4 0 and 4 1 came from this 5 1, so the value of 5 1 is 5, and 5 plus 1 will be 6, and the 6 value will be returned to this 6 1. Okay, this 6 1. So the value of this 6 1 will be 6, and we'll return this 6 plus the value of 6 2 to this 7 2. But we have calculated only the one value 6 1. For the 6 1 we have get the value as 6, but we have not calculated the value of 6 2. We have to calculate the value of 6 2, and then we have to add it with the 6 1, and then we'll return it to the 7 2. Okay, for 6 2 we'll do the same operations here. So you can see here we have write the 6 2 here, and from 6 2 what we'll get 5 1 and 5 2. So you know how to get this 5 1 and 5 2. We'll decrease 6 by 1 and 2 by 1. So this will be 5 and 1, and next we'll add this with the another recursive call where 6 will be decreased by 1, which is 5, and 2 will be same, so which is 2. Okay, so here we'll check the conditions if k equals to 0 or k equals to n. No, you can see here k equals to 1 and k equals to 2. So here none of the conditions satisfied, but we have calculated the value of 5 1. So our value of 5 1 was here 5. this 5 was returned from these two values. So our value of 5.1 was 5. So we'll write the value of 5.1 here. So next we'll call the 5.2. So 5.2 will be 4.1 and 4.2. So we know the value of 4.1. So the value of 4.1 was 4. So we'll write it here. And next we'll call this 4.2. So 4.2 will be 3.1 and 3.2. And we know the value of 3.1 because we have calculated it. So the value of 3.1 was 3. So we'll write the 3 here. And next we'll call this 3.2. So 3.2 will be 2.1 and 2.2. So we know the value of 2.1. So our value of 2.1 was 2. So this is 2 and we'll write it here. And we check if k equals to 0 or k equals to n. So k is not 0, but you can see here n value is 2 and k value is 2. So n and k value are equal. So this will return 1. So there is no function to call. So this will go back to the main function where it was called. So we'll add this 2 plus 1. So 2 plus 1 is 3. We'll return this 3 to whom, from where it was called. So 3.2. We'll return this 3 to 3.2. So 3 and 3 will be added and we'll return this to 4.2. So 6 and 4 will be added, which is 10. So 10 will be returned to this 5.2. So now our value of 5.2 is 10 and our value of 5.1 is 5. So 10 plus 5 will be 15. So 10 plus 5 will be 15 and this value will be returned to 6.2 and our value of 6.2 will be 15. Okay, so before we have calculated the value of 6.1 was 6 and now we have calculated the value of 6.2 which is 15. And we'll add these two value and return these to 7.2. 7.2 value will be 6 plus 15, that is 21. Till now we have calculated the recursive call of 7.2 and its values. Now we'll add this value to the 7.3. But we have to recursively call the 7.3 and we have to calculate the value and we have to add it to 7.2, which is 21. So to calculate the value of 7.2, we'll do the same operations here. First we'll call this. First we'll do a recursive call. So our rule was we'll decrease the n value by 1 and the k value by 1. So 7 will be 6 and 3 will be 2. And next this will be added to 6 and 3 because n value will be decreased but k value will be same. So we know the value of 6.2. So what was our value of 6.2? Our value of 6.2 was 15. We'll write the 15 here and we'll call this 6.3 again. So from this 6.3 we'll get 5.2 and 5.3 and we know the value of 5.2. So what was our value of 5.2? So you can see here our value of 5.2 was 10. So value of 5.2 was 10. So we'll write the 10 here. Now we'll call the 5.3. So here will be 4.2 and 4.3. So we know the value of 4.2. So value of 4.2 is 6. We'll write the 6 here and we'll call the 4.3 again. So 4.3 will be 3.2 and 3.3. So we know the value of 3.2. So our value of 3.2 is 3. We'll write the 3 here. And here we'll check if n and k are equal or k equals to 0. So here you can see our n value and k value is 3. So our condition is satisfied and there is no further functions to call recursively. So we'll add these to 3 plus 1 4 and we'll return this to the previous function. So 3 plus 1 equals to 4. 4 will be returned to here and 4 plus 6 will be 10. 10 will be returned to here and 10 plus 10 will be 20. 20 will be returned here and 20 plus 15 which is 35. 35 will return to this 7.3. So previously we have calculated the value of 7.2 which was 21. Now we have calculated the value of 7.3 which is 35. So we have calculated all this value and we'll add this 21 plus 35 which is 56 and this will return our final result. So this is how to calculate the value of NCR in our program. So we can do it using a recursive call because there is no direct way to calculate the value of NCR like our calculator. Yes, the internally this is how the recursive function works. So hope you understand how to solve the binomial coefficient problem and how to solve the recursive problem. So hope you understand both of these concepts and hope you enjoyed this whole video and understand the basics of these two. And if you like this video, then please give it a big thumbs up and don't forget to subscribe. Or if you have any questions or queries or any coding problem, then please comment below. I'll try to help you. Thank you so much for watching this video.